This section is on equilateral triangles. In this section, you will learn how to recognize equilateral triangles in drawings and find the area of an equilateral triangle when given the side length. Let me add that this section can be deceptively simple because the basic information is simple, but some quite challenging problems can be drawn from this information. Here are some facts about equilateral triangles that you need to remember. All three sides have the same length. All three angles measure 60 degrees each. Here are some clues about how to recognize equilateral triangles in drawings. If you have an isosceles triangle and one of the base angles is 60 degrees, then the triangle is also equilateral in addition to being isosceles. If a triangle is drawn inside a circle and two of the sides are radii of the circle and one angle measures 60 degrees, then the triangle is equilateral. Here is a formula for the area of an equilateral triangle. If you know the side length S of an equilateral triangle, you can find the area using the following formula. A equals the square root of 3 over 4 S squared. Here is an example of how to find the area of a triangle. We are given a circle with center at A, and a triangle is drawn into that, and we're told that one of the angles is 60 degrees and that the radius equals 4. We know it's equilateral because of what was discussed in the previous slide. And since the radius is 4, one of the side lengths of the equilateral triangle is also 4. We go to the area formula, A equals the square root of 3 over 4 S squared. We replace S with 4 and do the math. And the final answer is 4 square root of 3. Here are some practice problems for you to try. Pause the DVD after each problem and come back for the answer when you are done. Practice problem 1. Find the area of an equilateral triangle that has a side length of 3. The answer is 9 square root of 3 over 4. All we are doing is substituting 3 for S and doing the math. This gives us the area equals square root of 3 over 4 times 3 squared. 3 squared is 9. The answer is 9 square root of 3 over 4. Practice problem 2. Find the area of the equilateral triangle below. How do you know the triangle is equilateral? Answer to practice problem 2. The answer is 25 square root of 3 over 4. A equals square root of 3 over 4 times S squared. S is replaced by 5 and we square it. We get 25 square root of 3 over 4. The triangle is equilateral because two sides are radii of a circle and are congruent. Since one base angle equals 60 degrees, the others must equal 60 degrees also. The only possible value for the vertex angle is also 60. Here's practice problem 3. A rhombus with a side length of 5 and a 60-degree angle is shown below. If the diagonal DB is drawn, how do you know the resulting triangle is equilateral? Here's the answer to practice problem 3, which is just really testing your memory of what a rhombus is. A rhombus has 4 sides of equal length. Therefore, all sides have a length of 5. The diagonal BD creates triangle ADB. Because two of the sides are both 5, the angles ADB and ABD must be congruent. Setting up an equation to find the angle measures gives x plus 60 equals 180, and going through the algebra gives a result of x equals 60. Hence, the triangle is equilateral. Here's practice problem 4. We're given the same figure we had earlier, and you're told, draw the diagonal BD. What is the area of triangle ABD? Here's the answer to practice problem 4. The answer is 25 square root of 3 over 4, and we're substituting into the area formula. Practice problem 5 is quite challenging, so don't feel bad if you can't do it. What you're to do is use your knowledge of special triangles to find the length of diagonal AC and the rhombus below. It's the same rhombus we've been working with in the other slides. Remember that the rhombus is a special case of a parallelogram and that the diagonals of a rhombus bisect the angles. You will need to draw an altitude to AC to get a 30, 60, 90 triangle. Here's the answer to practice problem 5. The answer is 5 square root of 3, but let's examine how we got to it. Look at the figure on the left. The diagonal AC will bisect the original 60-degree angle into two 30-degree angles. Now draw height DE, and that's shown in the diagram on the right below, and follow the rules for special triangles. DE is the shortest side of a 30, 60, 90 triangle. Since the hypotenuse is 5, the shorter leg will be 2.5, and the longer leg, which is AE, will be 2.5 square root of 3. Both AE and CE equal 2.5 square root of 3. Together, the two pieces add to 5 square root of 3. Here's practice problem 6. Find the area of the figure below. Draw a line to separate the figure into a rectangle and a triangle. The answer to practice problem 6 is 20 plus 25 square root of 3 over 4. The line BC separates the figure into a rectangle and an equilateral triangle. The area of the rectangle is length times width, which is 5 times 4 equals 20. The area of the equilateral triangle is square root of 3 over 4 times 25. Those two are added together to give the answer. Here's practice problem 7. Equilateral triangle ABC has side lengths of 4. The midpoints of its sides are located at points E, D, and F. Those midpoints are joined to form a new triangle. What is the area of the new triangle? Here's the answer to practice problem 7. The answer is the square root of 3. To see why the new triangle is equilateral, look at triangle BED. Segments BE and BD are equal because they are each half the length of the original equilateral triangle. Additionally, angle B equals 60 degrees because it was the angle of an original equilateral triangle, and angle D and E are base angles of an isosceles triangle. Algebra will show that x must equal 60 degrees. Hence, the triangle is also equilateral and side DE equals 2. Similar logic will show that sides EF and DF equal 2 also. Hence, the triangle is equilateral. Use the area formula for equilateral triangles, and substituting into the area formula will give you the result that the area equals the square root of 3.